So far in this unit, we have been reviewing what area is, and we've been taking that to the next level and talking about surface area. Now we're going to take our measurement unit into volume, and so we need to differentiate between the two concepts of what is volume and what is surface area. So we'll start with surface area. Surface area, as we've been looking all along, is the amount of area on the outside of a 3D shape. So that's taking all of the faces and adding them up to get the surface area. So if we think of it in context of like a present, we'd say the surface area is how much wrapping paper does it actually take to cover this present. But now volume, we're going to move into, volume is different. Volume is talking about the amount of space a 3D object occupies. And what we mean by that is if we go back to that present analogy, if the surface area is how much wrapping paper goes on the outside of the present, the volume is how much space that present actually takes up in the room. So if we're thinking about Christmas, how much space does that take up under the tree? If you're hiding a present, how much space does that present actually take up in your closet? And there's two other things we need to differentiate, in which we've seen here. When we're talking about area, our units are always squared. So square centimeters, square meters, square miles. When we're talking about volume, we're now talking about if I was to fill this thing with little cubes, so our units are cubes, how many cubes does that take up? How many cubic feet? How many cubic centimeters? So on and so forth. So that's the difference. And now we're going to talk about the volume of prisms. Now prisms, remember we said just basically maintain their shape throughout, and we got 3 prisms down below in these examples. But the volume of any prism is just taking the area of what it's sitting on, or its base, and multiplying it by the length of the entire object. So we'll look at all 3 of these with this formula. So all of them are going to have volume of the area. Volume is the area of the base multiplied by its height. So we'll start with this rectangular prism. So the area of this base, the base of this thing, is actually a rectangle. And we've said that the area of a rectangle is length times width. And then we're just going to multiply it by the height of the whole object. So then the bottom is a 10 by 6 rectangle, and that goes up for 4 centimeters. And if we multiply those, we get a volume of 240. And now our units are centimeters, so we're saying if I was to make little cubes, centimeter cubes, 240 of them would fit into that shape. So that's the volume of that rectangular prism. Now we'll move on to the cylinder. And we said the volume of any prism or cylinder is going to be the area of its base multiplied by how high it is. Now the base of this object is a circle. So we can now complete this and say, well, the area of the base, the area of a circle is pi r squared, and we're going to multiply that by the height of this object. So then the volume is pi. Looking at our diagram, we do have a radius described to us of 4. So pi times 4 squared, and then times the height of the whole cylinder, which is 12. Putting that into our calculator and thinking about brackets and exponents, we get 603.2 cubic centimeters. So again, if we were to fill this with little cubic centimeters, we'd have 603.2 of them. Now the last one is one that usually seems to trick people up. This is a triangular prism, and it still holds true that it is the area of its base multiplied by the height of the whole object. Now when we talked about prisms, we talked about them being named after their base. So although that this thing's actually sitting on a 7.5 by 10 rectangle, the base of this is described by its name. The base is actually its triangle. So if we could figure out the area of this and then multiply by the height, basically if we were to stand it up to make the prism look more like this, we could find the volume of it. So we know that the area of a triangle is base times height divided by 2. So we have base times height divided by 2 for the triangle piece. That's this. Now multiplied by the height of the whole prism. And the height of the whole prism is 10. So I'll put that with a capital H because they're actually two different heights we're talking about. So the volume of this would be 7.5 times 6. That's the base and the height of the triangle divided by 2 multiplied by the height of the whole triangle, which is 10, which is this if we were standing it up. So multiplied by 10. Again, I suggest to let your calculator do the work for you here. And if we were multiplying out, we'd have 225 cubic centimeters for this triangular prism. So it's important that we recognize that the base is actually determined by what the prism is named after. Now we're going to move on to a different type of question that has a shape that we've never really found the area of before, but we'll work our way through it. We said we have construction workers working to fill this wooden form with concrete to form a footing for a bridge. Now it says the base is a regular octagon. Octagon means there's 8 sides, and you can count it down here in this diagram. This is what they're putting down, this octagon, and it says the form is 0.6 meters tall. Now if you look at the diagram, it's kind of hard to see. This is 30 centimeters, and then this is 36 centimeters. So we do have a whole bunch of triangles in there. But the other thing we should notice, this is given to us in centimeters. This guy's given to us in meters. We need to get our units together in the same unit. So 0.6 meters, there's 100 centimeters to every meter. So let's just change this to 60 centimeters. Now we'd have enough information to work with this. So what the diagram's saying is they're going to pour inside here some concrete, and they're saying how much concrete do we actually need? So again, we just need to talk about the volume. It's a prism. It's the area of the base multiplied by its height. Now since the base is an octagon and there is no real formula for the base of an octagon, the diagram does a great job here at letting us see what an octagon is actually made up of. It's made up of 8 triangles that are congruent, and congruent means the same size. So if we could figure out the area of one of these triangles and multiply it by the remaining 8, that'd be the area of its base. So if we looked, they are triangles. That's base times height divided by 2 for one of those triangles, but we're going to multiply that by 8 now because there's 8 triangles around this shape. And now this whole thing now needs to be multiplied of the height of this footing. And the height of the footing is up here in the description. It's 0.6 meters tall, whereas we said 60 centimeters. So now let's go through and fill in what we know about the triangle. Remember, base and height in a triangle have to make a 90-degree angle to one another. Here's my base. It's 30. My height is 36. That's this, making the right angle. We divide that by 2, and that would give me one of the triangles. But there's 8 triangles in that base to make the octagon. And then this whole thing is 60 centimeters tall. So this will tell us our volume. Go through and put these numbers into our calculator. We should have 259,200 cubic centimeters of concrete. So we found the volume of this strange shape, this octagonal prism. Now, prior to this video, you were asked to watch 2 videos on YouTube that kind of describe the relationship between pyramids and cones and their volume in respect to the prism they fit in and the cylinder they fit in. And you should have noticed in those videos that if you have a prism like this, the rectangular prism here, if I was to make a pyramid inside that shares the base and is the exact same height as it, this pyramid will take up exactly 1/3 of its area, or sorry, 1/3 of its volume. So if I can find the volume of the prism it fits in, all I need to do is divide by 3 or times by 1/3, and I'll have the volume of this pyramid. So first off, let's just say if I want to find the volume of the square-based pyramid in this diagram, they're showing us that it fits inside this rectangular prism. So any prism is just area of the base times its height. But now since we're talking about the prism, or sorry, the pyramid, we need to multiply this by 1/3. Now, another way to write this is just to say I'm going to find the area of the base multiplied by the height, and then take that final answer and divide it by 3. Dividing by 3 and multiplying by 1/3 are the exact same thing. So a rectangular prism, it's sitting on this rectangle, or they say a square. So we have a length times width, and then times the height of this whole pyramid or prism. And then we're going to divide this by 3. Now, since it does tell us it's a square pyramid, this dimension's also 6. So then we have the length and width, 6 times 6, multiplied by the height of the whole prism, which is 8.5, and we just divide that whole thing by 3, because that'll describe the pyramid that fits inside. So now in our calculators, we can just say 6 times 6 times 8.5. This would tell me the volume of the prism, and now I want to divide this by 3 to get the pyramid that fits inside. The volume of that pyramid would be 102, and my units are centimeters, so cubic centimeters. So I could fit 102 cubic centimeters within this pyramid. It's always 1/3 of the prism it fits in. Likewise, when we jump into this question, we're talking about a cone. And what you should have realized from those videos you watched, if we have a cone that fits inside of a cylinder, so the base is the same and the height is the same, the cone will take up 1/3 of the volume of that cylinder. So again, we have this question where we're saying somebody wants to make this shaping tool for bracelets, and she needs to make a solid cone. The cone has a radius of 2 inches and a height of 10 inches. What is the volume of this mandrel, or this sizing tool? So we could say that this cone actually would fit inside a prism, or sorry, inside a circular prism or a cylinder of this shape. The radius of that shape would be 2 inches. Its height would be 10 inches. And if we're taking just the pyramid, or sorry, the cone inside, we're going to end up dividing by 3. So again, we'll have, for the cylinder, area of the base times the height, but you just want 1/3 of it. And most people like to look at it this way. It makes a little bit more sense to them to say, if I find this and divide by 3, I have the cone. Now the base of a cylinder is a circle, so the area of the base is pi r squared times the height, and then we'll end up dividing by 3. Putting in our numbers, I have pi. The radius, they give it to us as 2 inches, times the height, which is 10 inches. So if I just left it like this, I have the cylinder, but we want that cone inside, so I divide by 3. And again, I'll show you what this looks like when we do this in our calculator. We're going to have pi times the radius squared times 10, and that's the cylinder this cone fits in. But since we're talking about a cone, it only takes up 1/3 of its volume, so we divide by 3. The volume of this cone now is 41.9 cubic inches. So just to go back and talk about the connection between volume of cylinders or prisms and the volumes of the cones or pyramids that fit in it, anytime we're finding the volume of a prism, we just need to find the area of its base and times it by its height. But if we're putting inside a cone or a pyramid, as this question did, and the following question, we're saying, you know what, there is a relationship between the cylinder that this cone fits in and the prism that that pyramid fits in. And the relationship, as you saw in those videos that you watched prior to this of the man filling up things with water, it is exactly 1/3 the volume of the prism that it fits in.